Let's go ahead and get started with today's lesson. So it's going to be short, a sort of short lesson today. It's not a lot to do, but this lesson is going to help us actually understand how energy transfers because we're going to model it in one of our sims today, which is going to actually be a different sim. But let's go ahead and remember that we're helping out the superintendent at the Stellwagen Bank National Marine Sanctuary. We're still focused on the bottlenose dolphins and them being able to communicate underwater. Answering this big question this time: how does sound energy travel? We know and have learned already that sound can travel through different kinds of materials. And when we think about the different kinds of materials, we're thinking about air, the ground, and water. We've also learned that materials are made of particles that are too small to see. We've seen those orange dots in our simulation with the sound waves, and so we know that those orange dots represent particles, and that simulation actually helped us understand how particles move. But remembering, because they are too small to see, particles are all around us. We're just unable to see them because they're so tiny. We've also learned last week and this week that sound travels as a series of collisions between particles. So the other day we did a coin experiment, which allowed us to model and represent particles that would collide into one another by using those coins to collide into one another. So that's very similar. We're also going to talk about collisions and particles today as we talk about energy transferring from particles to particles. We've also learned that sound energy travels as a wave. The particles of the material it travels through move only a little. When we think about answering the big question, all of these key pieces of information here is going to help you on your CER. So when we're thinking about answering the question for our CER, we need to think about language like this, right? We need to think about particles colliding. We need to think about sound energy traveling as a wave. On our last assessment, I noticed that a lot of KIPsters, you were talking about the mother dolphin being able to communicate by sound. However, we missed the point of the sound traveling as a wave, and we missed the point of how that energy travels from the mother dolphin to her calf. So we need to remember, as we're continuing to learn more information, we need to retain that information so that we can put that into our CER when we are answering the question for the superintendent. Our vocabulary word today is transfer. What does transfer mean? Transfer means to move something from one place to another. I want to remind you, as you are completing your PDNs, you need to make sure you are writing the definition that is in the blue, the definition that is in the slide, which is always right here, which I include in your classwork in blue. The reason I'm asking you to make sure you're using this vocabulary word, or I'm sorry, this definition, is because we want to be on the same page. We also want less complicated definitions. When you Google definitions, oftentimes it's going to give you a more difficult definition. So let's make sure we're using the definition that is in blue. Let's make sure we are making things easier for ourselves as opposed to making it harder for ourselves. In your PDN, when I'm asking you to write the definition, simply look up here in the blue and with your vocabulary word, and this is your definition. This is the definition that I'm expecting you to rewrite in that box. Please don't make it more difficult for yourself. Please don't go get a more complicated definition, but let's use what's available to us. Let's go ahead and go over our heading for today. So again, we are modeling energy transfer in this lesson. Here's your sim. This is the link that's going to take you there when you need to get to it. Our objective for today: I will be able to model the transfer of energy when particles collide. We are going to use the sim to actually help us model this transfer of energy for today. As usual, you have in blue your vocabulary word for today, and it gives you your definition, which means to move something from one place to another. And we are actually familiar with this word because we've seen it before in one of our previous units. When you are answering your PDN, because I'm noticing a lot of KIPsters are rushing through work, please make sure you are using sentence starters. Please make sure you are reading the question and properly understanding what the question is asking you. Use the illustrations that are available to you. Make sure you are turning in high quality work, whether you are in class, whether you are at home, wherever you are, you want to make sure you are giving your best, doing your best, and including sentence starters is part of turning in high quality work. That's what I'm looking for when we think about shout outs on Wednesday. When I think about shout outs on Friday, I'm thinking about the Kipster that is completing work with high quality, not completing work so that they can get to whatever else they want to do throughout the day. This is still your learning, and we are still helping you prepare for the 5th grade. So let's make sure we are taking it very seriously. This is what you're going to complete independently after we go over the simulation and after we go over the diagram. I will come back to this to make sure we are reading the directions and understanding them clearly and making sure we're following the directions, because this is something else that I'm noticing in classwork. We're bypassing these directions, and I'm not certain why. Directions are there to help you. You cannot complete the assignments properly. You cannot get all of your credit if you are not following the directions, if you never click into your simulation. These are the things that are going to cost you and boosting your grade. So you want to make sure you're doing the work, make sure you're putting in the effort, because I am not giving you full credit for work that's not being completed with effort. So please know that. So we'll come back to that, to these directions as we get into our simulation. So this is the simulation that we're going to get into, and here's the reason why. We want to apply our understanding of how energy is transferred through particles. So this is a little different from the sound wave simulation that we've been working with. In the last simulation with sound waves, the particles were actually moving. In this simulation, you're going to notice that the particles are not moving, but we still want to make sure we actually understand how energy is being transferred with these particles. And so we're going to do the diagram together. I also suggest you go into the sim on your own and complete the diagram, play around with the sim by completing the diagram on your own, because that will also help you have a better understanding. So in your classwork, again, your link for the simulation is up here. You will simply click that link. And once you click that link, it should bring you to this page. If when you get to this page, if you do not get to this page and you get to the Amplify homepage and they're asking you for login information, please remember to go to your assignment. Attached will be the Amplify login information sheet. You can log in with that information. We're not going here, but instead we're going to click, as it states in your classwork, we are going to click the blue number 1 particle model. So when I get to my simulation, I'm going to click the blue number 1 particle model, and it is going to take me to the simulation that's going to help us model energy transfer today. So now that I'm in this simulation, this looks very much like the slide that we just watched. I want us to think about I want us to think about what needs to happen. So obviously right here, they're showing me that I have my mother dolphin, and they're showing me that I have the calf. So we need to figure out, using these labels and using the icons that are available to us, we need to figure out how energy is going to be transferred so that the sound goes from the mother dolphin to the calf. So I'm going to think about what's available to me. I have my labels, source, and the listener. And so my question to you is, between the mother and the calf, which is the source? Take 5 seconds to think about that. The mother dolphin is the source because that is where the sound is going to come from. When we think about it, the definition of source, that is where something comes from. If mother dolphin is originally making the sound, then she becomes the source in this situation. If she is the source, the sound, who is the listener, right? That leaves the calf. So I'm going to go ahead and take this label and put it over underneath the calf. Now, what they're showing me is the zoomed in model of water particles, right? This is as if the dolphins are in the water, in their habitat, and communicating with each other. So this is a zoomed in portion of that. And so I see what is similar to the sound waves simulation, I'm noticing these dots, which represent particles, and I'm also noticing a pattern. So this pattern is going to help the mother dolphin get sound to the calf when they are separated. And so I need to show in what direction the energy is going to travel in if the source is right here and the listener is right here. Where would what direction would I need to put my arrow in? Here you can move the arrow. The minute you put your arrow down, you'll get this little toggle thingy right here that will help you shift it. So I want you to take 5 seconds and I want you to think about which way I should point and which way you're going to point when you work on this independently. This arrow, if I'm thinking about sound having to travel from the source to the listener. The energy and the sound to travel towards the listener from the source. Don't forget, when you think about the definition of wave, that is information that is being moved away from the source, right? That is energy being moved away from the source towards the listener. That's how sound gets to the listener. Now we need to think about the energy transfer. Where is the energy being transferred? What is happening? And so this one is a little more tricky, and this is sort of our learning piece for today. When I think about the energy being transferred, I know that these particles must collide with one another in order for the energy to actually be transferred. It's almost like playing tag in a way. So like if this particle was to tag this particle and this particle tag this particle, that's what's going to help shift the energy. So I need to put one of these little guys, the energy transfer, right here on this pattern, because this is where the particles are colliding. So wherever you see the particles colliding, that is where energy transfer, that is where energy is actually being transferred. So again, whenever you see particles colliding, that is where your energy is actually being transferred. The particles have to collide with one another in order for the energy to actually transfer to eventually get to the listener. So I'm going to take these energy transfer icons and place them on these patterns because these patterns represent collision. So some of our questions when we completed our work the other day asked, well, we noticed the pattern happening, but why? Why are the particles lining up in this formation? And this is why. The particles need to actually, again, collide with one another in order for energy to be transferred, in order for the sound to go from the source to the listener. So this is how your diagram should look when you think about the mother dolphin being able to communicate with her calf, because here we see that the particles, right? We see these are not air particles, but we see the water particles. We see the formation. We see them colliding. We know that the water particles need to actually move towards the listener, which is why we put our arrow towards the listener. And we know that the energy is being transferred when they come together. When they come together, they're bumping into one another, they're colliding. That is how the energy is being transferred. That is how the waves are going to be shifted towards the listener. Here's another example of how your diagram should look. For me, my energy transfer icons weren't in a straight line like that, which is fine. Just make sure your energy transfer icons are actually on the pattern, that straight vertical line, because that's where the particles are actually colliding. So what I want us to sort of recap and think about, because this is going to help you answer your question correctly in your assessment, which is coming up this week. I want us to go ahead and recap this diagram and think about what's important here. We need to remember who the source is in this situation. The source is the mother dolphin. And when we're writing, we can use that scientific language because we know it. So if we want to say, The source is the mother dolphin. The sound is coming from the source. The sound is going to the listener. That's going to help you boost your grade in your CER because you're using that scientific language. So in this diagram, we have the source, we have the listener. That is very important that we know who is who. If we don't know who the source is, we don't know what direction the sound waves are going to move. So it is very important, again, that you know what the source is or who the source is. Now that we know that the source is the mother dolphin, we know that the sound waves are actually going to go towards the listener. So your arrow should be pointing towards the left of the screen. We know about our energy transfer bubbles, these little icons right here. We now know that energy is being transferred as particles collide into one another. If the particles do not collide into one another, the energy is not being transferred in a way that is going to help get sound to the listener. So you need to really remember that. You also need to remember that because that is a question in your class, in your classwork. So I'm going to say it again. In order for this energy to fully travel to the listener, the particles need to collide with one another in order for the energy transfer to happen. So when I think about energy transfer, I think about the particles colliding into one another. I think about the particles bumping into one another, right? I think about these particles playing tag with one another in order for sound to get to my ear, in order for sound to get to the calf's ear. When you complete your work, let's go ahead and go over what that looks like. So here are the directions again that you're going to follow. It's exactly what I did in my simulation. To get there, you need to follow these exact directions, you guys. Please make sure you are reading carefully. Please make sure you're following the steps so that you can understand what's happening in your simulation. You're going to click on the sim particle model, which I did, which was the blue number 1. You're going to add your labels, your arrow, and your energy transfer icons. After you do that, you're going to go ahead and answer the questions below. So based on the diagram, how does sound energy travel from the mother to the calf? Describe what is happening in your diagram. Sentence starters. Sound energy is traveling from the mother to the calf, and you're going to tell me how. How is that happening when you look at your diagram? So again, I explained it in this video, how sound energy is going to get to the listener from the source. If you are watching the video, you should not have a problem answering this question. What is happening when one particle collides into another particle? You want to think on the terms of energy. What is happening with that energy when one particle collides into another? Your simulation is giving you language that's going to help answer that question. You completing the simulation is going to help answer that question. Can sound travel without particles colliding into each other? Why or why not? So this is not just a yes or no. You need to give me a yes or no and explain why you think yes or why you think no. If you have questions on this, don't forget to send me a private message or on Google Classroom or text me because, again, it is very important that you're understanding this information and I don't want you to miss anything that's going to cause you to not do well in your assessment that's coming up at the end of this week. Now, let's go ahead and think about the big question and think about and sort of recap again. How does sound energy travel? Sounds can travel through different kinds of materials. Materials are made of particles that are too small to see. Sound travels as a series of collisions between particles. So when we think about this, sound travels as a series of collisions. I'm going to go ahead and quickly bounce back to my simulation. Sounds travel as collisions, right? The particles are colliding right here. And so this is a representation of a series of collisions and what that looked like when you think about it, particles colliding. And then you have sound energy traveling as a wave. The particles of the material it travels through move only a little. Those little guys do not move in great distances. They only move in short distances. Please remember your exit ticket as well. I'm noticing that we are not fully completing exit tickets. When you think about your exit ticket, use all of what's available to you. You have your scenario. Please use the images above to help you with that scenario, to help you answer the questions. When you answer this question, make sure you are answering with sentence starters and make sure you are including these words. Including these words are going to help you as you write your CER in the upcoming test this week. Make sure you answer both questions.